This semester, I'm working with Hiwonder's JetHexa Ross robot. The purpose of Project 1 was to get accustomed to the robot's features and performance, as well as familiarize myself with Ross. The JetHexa is a hexapod robot, meaning it has 6 legs. Each leg has 3 degrees of freedom through servo-actuated joints, meaning the entire system has 18 degrees of freedom. Hardware-wise, the robot is operated by NVIDIA's Jetson Nano, a small but powerful computer board that sports a quad-core CPU and 4 gigabytes of memory. It allows for resource-intensive operations such as computer vision, robot piloting, and artificial intelligence to be performed in rapid succession, even simultaneously using multi-threading. The Jetson Nano also generates its own Wi-Fi network, allowing the user to communicate with the JetHexa by connecting to it. Additionally, this JetHexa model is Hiwonder's advanced kit, meaning it has a 3D depth camera and LiDAR to support projects that utilize SLAM navigation and mapping. On the software side, the robot runs an Ubuntu Linux distribution and is controlled through the Robot Operating System, also known as ROS. When it comes to controlling the robot, Hiwonder provides 3 accessible options: control through the Wonder AI Android app, a wireless PlayStation 2 controller, and control through No Machine, a remote desktop application. For this project, I mostly utilized the first 2 options, but with more experience with ROS, it's highly likely that No Machine will become the primary method of control. This is because it allows users to implement custom ROS packages, opening the door for more project-specific operations. The following clips utilize the wireless controller. The robot has 2 gates, tripod and ripple. In tripod gate, the JetHexa moves in a march style, where 3 legs are lifted in swing phase and the other 3 remain grounded in support phase. The even and odd numbered legs alternate between swing and support phases, keeping the robot dynamically stable by resting its center of gravity within the triangle formed by the supporting legs. Ripple gait is a little more complex. Essentially, the robot cycles through diagonal legs to create a rippling effect, where no more than 2 legs are lifted at a given time. Qualitatively, this gait feels more like an insect crawling and is a more fluid motion. Hopefully, the provided clips help build a more intuitive understanding of how the gate works. In addition to having multiple gates, the robot is also able to modify many parameters, such as movement speed, step height, stride length, and even body posture through axial tilts. After I felt more comfortable piloting the robot, I moved on to other JetHexa features. One of the benefits of the Wonder AI app is the array of modes that allows users to experiment with JetHexa's features. In the robot performance mode, the user can command the JetHexa to perform a series of predetermined movement sequences. These sequences give an idea of the types of complex movements the robot can be programmed to perform. There are 8 predefined movements in total: stretch, fight, kick, attack forward, attack backward, mark time, twist, and wave. The LiDAR mode has 3 different sub-options. The first is obstacle avoidance, where the robot must prevent collisions within a given detection range. Next is LiDAR following, where JetHexa has to move closer or further away to maintain a defined distance between itself and an object. Finally, the LiDAR mode includes LiDAR Guard, a mode that makes JetHexa track and continuously face an object within its detection range. Based on these features, we can see that the LiDAR can be used for very interesting applications. Finally, To display the computer vision/AI side, Hiwonder included the gesture control mode. In this mode, the user can command JetHexa to move translationally using a single finger. The program detects hands pretty well, but the mode's efficacy declines as the robot moves farther away from the Android phone. This is because the Wi-Fi produced by the Jetson Nano has a very limited range. Overall, we can see that the JetHexa is a very advanced robot capable of a variety of functions. My goal for future projects is to write a ROS package that can combine many of these features to perform a task such as navigation through a confined space or path. To do this, I will need to acquire more knowledge on ROS development and continue to study the JetHexa source code to learn how systems such as LiDAR is controlled. Thank you for watching. I look forward to a fun semester.